Size separation. Size separation. A special technique is used to separate particles of specified size, which is known as the process of size separation. Official standards for powders. The Indian Pharmacopoeia has laid down the standards for powders for pharmaceutical purpose. The IP specified 5 grades of powder which are as under. First one is coarse powder, a powder of which all the particle passes through a sieve with nominal mesh apertures of 1.70 mm, that is sieve number 10, and not more than 40% through a sieve with normal mesh apertures of 355 on. Sieve number 44. It is called as a coarse powder. Then moderately coarse powder, a powder of which all the particle passes through a sieve with nominal mesh apertures of 710 mm, that is sieve number 22, and not more than 40% through a sieve with nominal mesh apertures of 250 nanometer, that is sieve number 60, is called as moderately coarse powder. Third one, third one, moderately fine powder. If all the particles of a powder passes through a sieve with nominal mesh apertures of 355 nanometer, that is sieve number 44, and not more than 40% of through a sieve with nominal mesh apertures of 180 nanometer, that is sieve number 85. It falls in this group. Fourth, fine powder. In case all the particles passes through a sieve with a nominal mesh apertures of 180 nanometer, that is sieve number 85, it is called as fine powder. Very fine powder. If all the particles of the powder passes through a sieve with a nominal mesh apertures of 125 nanometer, that is sieve number 120, it is said to be very fine powder. Sieves. Sieves for pharmacopoeial testing are constructed from wire cloth with square meshes woven from wires of brass, bronze, stainless steel or any other suitable material. The wire should be of uniform circular cross section and should not coated or plated. There should not be any reaction between the material of the sieve and the substance which is being shifted from it. So here is the various size and sieve number. Standards for sieve used for pharmacopoeial testing must specify the following. First, number of sieves, then a sieve number indicate number of meshes in a length of 2.54 cm in each transverse direction parallel to the wires. Nominal size of apertures. Nominal size of apertures indicates the distance between the wires. It represents the length of the side of square apertures. The IP has given the nominal mesh aperture size for majority of sieves in mm or in centimeter. Third is the nominal diameter of wire. Wire mesh sieves are made up from wire having a specified diameter in order to give a suitable aperture size and sufficient strength to avoid distortion of the sieve. Fourth one is approximate percentage sieving area. This standard expresses the area of meshes, a percentage of total area of the sieve. It depends on size of the wire used for any particular sieve number. Generally, the sieving area is kept within the range of 35 to 40% in order to give suitable strength to the sieve. Fifth one is tolerance average aperture size. Some variation in the aperture's size is unavoidable, and when this variation is expressed as a percentage, it is known as aperture tolerance average. Sieving methods. In this method, a fine powder is separated from the coarse powder by using a sieve of desired number. The degree of fineness of powder is known with the help of sieve through which powdered material is passed. Sieving are numbered in order to distinguish from each other. Size separation of powder is done by passing the powdered material through a set of sieve. Sieving are arranged in descending order, that is, sieve of larger size is at the top and the smallest one of the bottom. The bottom sieve is attached to the receiving pan. So here is a diagram of electromagnetic laboratory sieving machine. And here is the actual diagram of sieving machine. The material is placed in the uppermost sieve. The sieves are shaken with the help of mechanical sieve shaker or electromagnetic device. It helps the particles to pass through the sieve. The working of mechanical sieving device are based on any of the following methods. First one, agitation, second brushing, and third centrifugal. What is agitation? Sieving may be agitated in a number of different ways, such as oscillation. This sieve is mounted in a frame that oscillates a back or forth. It is a simple method, but the material may roll on the surface of the sieve. Second one is vibration. The sieve is vibrated at high speed by means of an electric device. The rapid vibration is imparted to the particles on the sieve, which help to pass the powdered material through it. Gyration. In this method, a system is made up so that sieve is on rubber mounting and connected to an eccentric flywheel. This gives a rotary movement of small amplitude to sieve, which is turn gives spinning motion to the particles that help to pass them through a sieve. Agitation methods are not continuous method but can be made so by inclination of the sieve and the provision of separate outlet for undersize and oversized particles. Brushing methods. In this case, a brush is used to move the particles on the surface of the sieve and to keep the measure clear. The brush is rotated in the middle in the case of circular sieve, but spiral brush is rotated on a longitudinal axis in case of horizontal cylindrical sieve. Centrifugal method. In this method, a high-speed rotor is fixed inside a vertical cylindrical sieve so that on rotation of motor, the particles are thrown outward by centrifugal force. The current of air which is produced due to high speed of rotor help in sieving the powder. On shaking the powdered material in a mechanical or electromagnetic device using any of the above method, the weight of powder retained on each sieve is determined. The percentage of each fraction is then calculated. Sieving method is a rapid process and it requires very little skill. The equipment used for sieving is not expensive. Cyclone separator. Principle. In cyclone separator, the centrifugal force is used to separate solid from fluid. The separation depends not only on the particle size but also on density of particles. Hence, depending on the fluid velocity, the cyclone separator can be used to separate all types of particles or to remove only coarse particles and allow fine particles to be carried through with the fluid. So here is the actual diagram of cyclone separator. Construction. It consists of a cylindrical vessel with a conical base. In the upper part of the vessel is fitted with a tangential inlet and a fluid outlet, and at the base it is fitted with solid outlet. Working. The suspension of solid in gas, usually air, is introduced tangentially at a very high velocity so that rotary movement takes place within the vessel. The fluid is removed from central outlet at the top. The rotary fluid within the cyclone separator causes the particles to be acted by centrifugal force. The solids are thrown out to the wall. Hereafter, it fall to the conical base and discharge out through solid outlet. Uses: cyclone separator are used to separate the suspension of solid in a gas. It can be used with the liquid suspension of solids. Next one is air separator. So principle, it work on the same principle as that of cyclone separator, but in this case air movement is obtained by means of rotating disc and blades. To improve the separation, the stationary blades are used. By controlling these blades and the speed of rotation, it is possible to vary the size at which separation occur. Construction. It consists of a cylindrical vessel with a conical base. In the upper part of the separator, the vessel is fitted with the feed inlet, and at the base there are two outlets, one for line particles and other for heavy particles. The rotating disc and rotating blades are attached to the central shaft to produce air movement. Working as shown in the sample, powder is passed through the feed inlet, which fall on the rotating disc. The rotating blades are attached to the same shaft. This produces a current of air as shown by the arrow. The fine particles are picked up and are carried into space. There, where air velocity is sufficiently reduced, the fine particles are dropped and ultimately collected at an outlet means for fine particles. The heavy particles which fall downward are removed on the outlet meant for heavy particles. Uses: air separator is often attached to the ball mill or hammer mill to separate and return oversized particles for further size reduction. Next one is illustration method. The size separation or powder is based on low density of fine particles and high density of coarse particle. Illustration tank is used to separate the coarse and fine particles of powder after levitation. The dry powder or paste made by levitation process is kept in an illustration tank and mixed with a large quantity of water. The solid particles are uniformly distributed in the liquid by stirring, and then it is allowed to settle down. Depending on the density of solid particle, it will either settle down or remain suspended in water. The sample is withdrawn at different height through the outlet. These are dried, and thus the powder with various size fractions are collected nowadays in illustration process. The particles are suspended in a moving fluid, generally water or air. The apparatus consists of a vertical column with an inlet near the bottom for suspension, an outlet at the base for coarse particles, and an overflow near the top for fluid and fine particles. The column width will give single separation into two fractions. If more than one fraction is required, the number of tubes of increasing area of cross section can be connected in series. The velocity of the fluid decreases in succeeding tubes as the area of cross section increases, thus giving a number of fractions. These fractions are separated and dried. So first, small a is the illustration method and small b is the multi-stage illustrator. Advantages of illustration method. First, the process is continuous. Second, depending on the number of fractions required, the same number of tubes of different area of cross section can be connected. Third, the separation is quick as compared to other method of separation. Fourth, the thus is more compact than as that used in sedimentation method. The main disadvantages of this method is that the suspension of solid particles has to be diluted, which may not be desired in certain cases. Bag filter principle. In a bag filter, size separation of fines. The fines are achieved in two steps. In the first step, the milled powder is passed through a bag filter by applying suction on the upper side of the feed entry. In the next step, pressure applied in order to shake the bag so that powder adhering to the bag fall off, which is collected from the conical base. Fabric platter with shake and reverse air cleaning. Construction. It consists of a number of bags made of cotton or wool fabric. A hopper is arranged at the bottom of the filter to receive the feed. At the top of the metal container, a provision is made for the exhaust. Adjacent to this, a bell crank level arrangement is made to bring the filters to normal atmospheric condition. Working. The working of bag filter consists of two steps. In the first step, the feed is separated from air by passing it through the cloth bags. In the subsequent step, bags are shaken to collect the fines that are added to the bags. Uses. It used along with the cyclone separator. Second, it is connected to the discharge end of the fluidized energy mill. Thank you.